Hello, hello. Hey, I'm audible. Hey, I tell you a story. So one hacker was review some code for a client, and he found something really interesting. They had this entire update system completely unverified, like literally no check, no where the data was coming from, or if it was tampered with. And I'm thinking, this is exactly kind of stuff that get companies breached. So that's what we're talking about today. uh, A08 software and data integrity failure. If you are doing code review or security assessment, this is something you need to know how spot, and honestly, it's pretty easy once you understand where to look first. All right. So first, need to understand um, what is the software and data integrity failure. So A08 is about one thing integrity. When you download an update, when you receive data from an API, when you pull in dependency, you are trusting that the data has not been messed with, right? A08 is when that trust is broken. It's vulnerabilities in software update, dependency management, and data validation that let attacker inject malicious code or tamper with critical data. Uh, let's give you uh, let's give you a quick example. Imagine you build banking app. Your app talk to backend API to get account balance, but the response from the API, no signature, no checksum, nothing, just raw JSON. An attacker on the network could intercept the response and change the balance from 100 bucks to million. You are displayed. So user see $1 million. That's a problem. Or think about software update. You download an update from the internet, no verification, and boom, you install malware. That's called H08 and software and data integrity failure. So basically, H08, when you don't verify the data or code, it's what it say it teach. So how you actually find this vulnerability during code review? Because that is the question, right? Where do you even start? Let let's break down into place you need to look. First, look at download and update. Uh, Whenever you see code downloading something the internet or update, file configuration, stop. Ask yourself, this is being verified. Look for this pattern. HTTP, HTTPS, or ignore SL error, no checksum, no signature. If you see any of this, you found a vulnerability. Second, look API response. Anywhere you code, anywhere your code is review data from an external source, check if they are validation. Look for mm, look for directly using response data await.response JSON. There is no signature. Check no HMAC verification, no timestamp validation. If the code just take the response and use it, that is A08. Third, dependency, and most important, this is a huge. Check your package.json or requirement.txt, whatever you are using. This is the red flag, any version or unpredictable or no integrity check. If dependency are pinned are not pinned to exact version, you are vulnerable to supply chain attack. Fourth, deserialization. If you see code deserialize untrusted data uh, like this or this, anything like this, immediately red flag. And finally, find the build system itself. This is something people miss. Even if your application code is perfect, And if your build system is compromised, if your build system is compromised, attacker can sign malware legitimately. Look at who has access the build system. Are commit signed with GPG? Are build artifact signed or not? Each there is audit log. So literally, when you review code, ask yourself, where does this data come from? Is it verified? Could it be tampered with? Like that. So now let's talk about actual testing for this stuff when you're doing assessment. When I'm looking for A08 vulnerabilities, I'm basically doing three things. First, I'm using bufsuit to intercept the response, and I will intercept an API call, modify the response data, change the number, change this thing, whatever, and I see if the application accepted it or not. If it does, that your vulnerability, that your vulnerability, then no integrity check. Okay. Second thing, I'm check update mechanism. How does the application get update? I look at how protocol, what's protocol, HTTP or HTTPS. Where is the signature verify? Is there a checksum? I'll try to do MITM attack and replace the update with something malicious. If it install or vulnerability confirm. Third, I'm checking dependency. Um, I look at the package manager, like package manager file, or version print, and is there a log file? I will try to update a package manual to a newer version or create a malicious one. And if the will pull it automatically, so basically the technique is find a place where data flow and try to modify it. See if the application detect the modification. If it does not, you found A08. So alright, left time enough theory. Let's break something. So let me show you what I actually look like in practice. I built interactive lab with demonstrate purposes. Let me open it up. Where it is? Here it is. No, no, not here. It is. Mm, maybe this one. Yeah, this one. So here's the thing about Azure Edge. It's not super obvious in code review sometime, but when you see it in action, it it click. This lab are designed to show exactly that. And check this out. So this is really a real vulnerability. The application download update without any verification. No signature, no checksum, and nothing. Just download and install whatever it gets. Okay. Look at the code. This is actually bad. The application is using HTTP or not HT using HTTP, not HTTPS. Ignore SSL error. Not checking if the file actually from the real server. Not verify a signature. Just execute whatever it download. Now what happened? Now what happened when attacker does an MITM attack? See how attacker intercept the the connection and replace the update with malware, and the application just install. That the vulnerability. There no verification at any step. Mm. Now we look at the secure version. Notice the different here. HTTPS with certification, signature verification with public key, checksum validation, backup before update, atomic operation, and that is what you should be looking for code in code review. So let's do another one. This one. This is data tampering, API return, no integrity check. Uh, See this. The application, the application received a response which balance $1,000, but attacker intercept it and change it to the $999,000. The application has and the application has no way to know the data was notified, so it accept it. Now look the secure way using AGM-AC. The server creates a signature of the data. If the attacker modify the data, the signature does not match anymore. The application rejects it. Simple but effective. So let me actually demonstrate this. I will enter some data, generate a signature, and see the signature. And now if I modify the data, and try to verify it, this one, okay, and you can see signature does not match, tampering detected. That's how you protect against this step. Okay, so one more, the dependency attack. This is huge in 2024. What happened, the developer install uh, Lotus, but developer install this, but there is a typo, mean the typing mistake, or a malicious package with a similar name. No verification, pinning, no version pinning. So everyone who run npm and install get the malicious version automatically. That's why you need to. That's why you need exact version pinning. Look file with checksum, regular dependency attack. The rest of the dependency attack. And okay, this one like this. So rest of the lab try at home your own. I provide in the description and comment section. So alright, uh, how do you actually fix this vulnerability? Because finding them is one thing, but you got fix them, right? So use for update use HTTPS with certificate pinning, verify cryptographic signature, check SHA 256 checksum, and keep backup, and implement rollback capability. For API response, add AGM-AC signature, verify timestamp, prevent reply attack, use HTTPS, and don't touch external data. For dependency, pin exact version, not range, exact. Okay, pin the exact version. Commit log file to version control. Use package log.json file. Run dependency audit regularly and use tool like npm audit and OWASP dependency check. For code commit, require JPG signature, verify signature before merge, maintain audit log, limit who can push to the main branch. And the big picture is defense in depth. Don't just rely on signature. Okay, add code review, automate testing, runtime monitoring, incident response plan. Because and this is important, if you have perfect signature, if your build system get compromised, an attacker can sign malware legitimately, and the SolarWind breach proved that. uh, now, so let's wrap up. So here the takeaway is basically asking one question during code review: can I trust this data? If the answer is no, is there any way an attacker could modify code or data without detection? You found a vulnerability. Start using this checklist. Using checklist. Use the lab to understand how this attack works. Sorry, and when you review code, always ask where this is the data coming from. How do we know it has not been modified? If you want to deep dive, I have the link. I have linked the interactive lab detail guide in the description. So they are free and they are hands-on, and they will make you way better at spotting this vulnerability. So drop a comment if you have any question, and if you prepare for pen testing or interview secret admin, this is absolutely something you need to know. So thank you for watching. Good luck with your code review, and I'm seeing the next video. Bye.